Hello everyone, and welcome to another video about the hard decisions that you will have to make while running a SaaS product. Should you use Amazon Web Services or Google Cloud Platform? React or Vue.js? Which type of hosting is the cheapest? Which one scales the best? Oh yeah, a lot of decisions to make, and potentially hard and expensive to redo. I can't give you the final answer, but if you watch this video to the end, you'll be much better equipped to make an informed decision. Let's get started. For those of you who are new, welcome to this channel. If you don't know me already, I'm Simon. I'm a software engineer and entrepreneur, and I'm currently building FeedHive, a SaaS product that was born to make the life easier for content creators who care about quality and growth. A lot of you have been asking me about the tech stack of FeedHive, and in this video, I'll go through it in details and include some of the considerations that I had when I started building FeedHive. So, first of all, there are many ways to build a full stack application. There's also a lot of disagreement about the ideal tech stack of a SaaS product. I'm not saying my way is perfect, and I'm sure you can find a lot of developers out there that disagree with my decisions. That being said, let's break it down. Serverless Architecture. FeedHive runs cloud native on a fully serverless architecture. So, if you're not familiar with the concept of serverless, it basically means that your cloud provider is taking care of provisioning, maintaining, and scaling the infrastructure that executes the code running on your backend. You don't have to deal with storage systems, databases, containers, clusters, or anything like that. When you're bootstrapping a SaaS business, this is an extremely attractive solution given the pay-per-use pricing model that is often associated with serverless. This means that you pay per 100 milliseconds of execution time of your cloud functions, per read and write of your database, and per read-put of files on your file storage. This solution is not only saving you time and overhead, it also automatically scales as users come in and demand goes up. But most importantly, it's super cheap. On Amazon Web Services, I pay $0.08 per user per month on average. That means that with the current pricing model of FeedHive, if just 1 out of 62 users are on the paid plan, they will cover the server cost entirely. The components of the cloud. As I mentioned, FeedHive runs cloud native on Amazon Web Services. So, what does that mean? It means that everything that FeedHive consists of runs in the cloud, using different components that are all part of Amazon Web Services. Let's break it down. All data is stored in DynamoDB. DynamoDB is a managed database provided by AWS. It supports both key value entries and documents. That means that a field can contain a single value, such as a string or a number, but can also contain a document, for instance, a JSON object. It's schemaless. So besides a key, it doesn't rely on a predefined schema. You could think of this as a combination of a relation and document-based database, such as MongoDB. It's fully managed by AWS, so you don't need a server running to host the database. This enables extremely high flexibility when it comes to up and downscaling your solution. Think of it like this. In periods where barely anyone is using your platform, you don't have to worry about the cost of having a server running just to serve the few that do. GraphQL and AppSync. GraphQL is a query language and an alternative to SQL and MySQL. With GraphQL, we can specify exactly what we need and the relation between the data coming from the backend, all in a single request. AWS has a solution called AppSync, which enables you to create a managed GraphQL layer to securely access, write, and combine data from one or more data sources. You can link a DynamoDB table as a data source directly without having to write custom resolver logic. AppSync is again fully managed, so you don't need a server running your GraphQL API. Additionally, you can easily configure authentication based on an API token, Auth0, and combining with Amazon Web Services Identity Access Management System. Lambda Functions. The entire backend of FeedHive is written in TypeScript, executed in a nodejs environment running on individual Lambda functions that live in the cloud. This is an extremely powerful alternative to managing and provisioning servers for your backend. Even though you can link a DynamoDB table as a data source directly using AppSync, you typically need a bit more custom resolver logic. Fortunately, you can use Lambda as a data source for AppSync in itself. This allows you to write custom GraphQL resolvers whenever needed. And once again, yes, you guessed it. The environment that the Lambdas are executed in is entirely managed by Amazon Web Services. You only need to worry about exposing an endpoint or setting up a trigger event for your Lambda, and then AWS takes care of the rest. The pricing can be a little difficult to figure out at first, since both the duration and memory consumption is factored into the price. But essentially, you pay $0.00001667 for every gigabyte second and 0.20 per 1 million requests. If this sounds super cheap to you, it's because it is. There are definitely use cases where the cost will run up very quickly and where a pay per uptime model may be preferred. But for a lot of bootstrapping SaaS products, this is a perfectly ideal way to run a server. User authentication. Finally, Amazon Web Services has a great solution to handle authentication of your users called Cognito. With FeedHive, you log in using Twitter, which is a third-party social identity provider. Amazon Web Services call this federation. After authenticating with a social identity provider, Cognito will securely map the authenticated user to the roles that are allowed to access the resources on AWS that the user needs to access and use the app. Optionally, you can create a user pool, which is a managed user directory containing all the relevant information about the user. In this way, you don't have to worry about maintaining a user table in a database yourself. And here's where it gets really incredible. AWS runs a library called Amplify, which you can install on the front end and will help you tremendously with user authentication on the client side. They also have a CLI, which you can use to spin up an entire full stack in a matter of a few minutes. Especially for beginners, this is an incredible and easy way to get started. The front end. All right, let's jump to the front end. The front end of FeedHive is written in React. If you don't know already, React is a JavaScript library for building user interfaces. It's especially powerful for writing single-page application or so-called SPAs. By far the easiest way to get started with a new React app is using Create React App. It comes with a comprehensive toolchain for both developing, building, and shipping a React app. React has amazing TypeScript support as well. In fact, the entire front end of FeedHive is written in TypeScript. For the state management of the application, FeedHive uses Recoil, which is an upcoming Atom-based state management library. It's still in beta, but it's absolutely an awesome alternative to the tedious boilerplatey solutions that we currently have out there. After we have used Create React App to build our React app, we can simply upload it to the S3 bucket where the static files can be accessed, and we can make CloudFront expose it to the World Wide Web. CloudFront is a blazing fast content delivery network which we can use to direct traffic from our domain to the S3 bucket. This offers additional capabilities in regards to caching, load balancing, and much more. Client-server interaction. So, how does the front end interact with the cloud? Well, an important component is Amplify, which I mentioned just before. Amplify enables us to integrate a lot of the things that we have covered so far. Most importantly, it makes it really easy to manage authentication of the users using Cognito. FeedHive authenticates using Twitter as a social identity provider, but the options when combining Amplify and Cognito are more or less limitless. You can use any social identity provider like Facebook, Google, GitHub and Twitter, but you can also use enterprise identity providers like SAML or OpenID Connect. You can even use Amazon Web Services' own hosted authentication endpoint for absolute ease. Amplify also does provide a small client to interact with the GraphQL API through AppSync. It is, on the other hand, rather limited. With FeedHive, I chose to use the Apollo client from Apollo GraphQL, which offers really rich capabilities in terms of caching and state management. And fortunately, using Apollo client in combination with the AppSync GraphQL endpoint is fairly easy. Testing the application. I'm a huge fan of test-driven development, and I use this approach whenever the situation allows me to. Both the front end and back end of FeedHive contains unit tests written and run by Jest. Additionally, I'm a huge fan of Cypress, which I use rigorously for both integration tests and full end-to-end testing. As a part of the deployment pipeline, GitHub Actions will spin up a hosted test environment, which Cypress will use to run end-to-end tests against. This combination of having both unit tests and integration tests running on each module and end-to-end tests running on a hosted environment makes FeedHive really resilient to regressions. Deployment. So, finally, I want to mention the deployment setup. FeedHive uses the Serverless Framework. The Serverless Framework is a tool that enables us to develop, manage, package and deploy Lambda Functions along with all the resources they need to run with absolute ease. It allows us to use infrastructure as code for the entire cloud infrastructure. We can set up both DynamoDB, AppSync, GraphQL schema and all our Lambdas in a single YAML file. It is an incredible tool. As mentioned before, all deployment pipelines are run using GitHub Actions, which has really matured in the last couple of years. It also means that we can define the entire application and deployment specs as code using YAML and JSON. All right. As a software engineer by heart, I can easily get carried away here and talk all day about this. But I'll stop here and do a quick sum up. The biggest takeaway from the tech stack that I have chosen for FeedHive is that it's serverless. No need to manage servers. Pay per use instead of paying for uptime. Serverless is inherently scalable, reducing cost, energy efficient, and cheap. I collected a full list of all the resources that I have mentioned here, so check it out in the description below. If you have any questions, feel free to drop a comment and I'll try to answer the best I can. I hope you enjoyed watching and I hope you got some inspiration and ideas about how to architect the tech stack of your upcoming SaaS product. Keep an eye on my channel because I'm sharing tips on business, SaaS products and tech regularly. And if you didn't already, please give this video a like and remember to subscribe for more. I'll see you soon.